Thanks for coming, everybody. It's kind of cold in here, huh?
Take my jacket off and slowly chill up over the length of the talk. So my name's Anton Kuster. I'm a principal program manager on Azure CDN. I've been working in CDN since 2013, and around about that time was when the actual Azure CDN was built on infrastructure POPs that were owned completely by Microsoft. And starting in 2013, we started a journey with Verizon to go and start using their infrastructure. And then April 2014 is where pretty much the majority of traffic had moved over to them. And then shortly after there, all the traffic had moved over. And then in May of this year, we actually took on Akamai as a second infrastructure provider for Azure CDN. So now we're kind of a true multi-CDN, and that's part of the discussion we're going to have today. On my right is Peter Maston, who's the VP of Digital Strategy at Sidexis, and some background.
So my background is I have worked in the CDN space really since the early 2000s. I got into it in a big way in 2005. I was the CTO of a company called Multicast Media that implemented a multi-CDN solution. I then, a few years later, joined Internet and ran their CDN division for about 5 years. And along the way, I became aware of Sidexis, where I work now, who specializes in multi-CDN solutions. And I thought it was such a clever idea that they implemented that I picked up the phone one day and called them and said, hey, I want to come work there, which is what I did in about 3 years ago. So and we'll tell you a little bit more about Sidexis in a minute, but essentially they're a company that specializes in cloud-based multi-homing across multiple CDNs and multiple clouds.
So what I always want to do before I start one of these presentations is just get a show of hands first of how many people understand what a CDN does and when you should use a CDN. All right, so most of you know, but we'll do the first few slides. We'll go quickly through them. We're to walk through, just kind of set a basis for the talk in terms of why CDNs are important. There's also the if it would bounce.
I think you hit the other one, maybe the side one.
It loves me not. There we go. One of the things that we do see is that sometimes people think of, my favorite term is CDN's magic pixie dust. You can just put it everywhere, and that's not really, it's not the case. Now, CDNs matter when you need performance, when you need scale, and they're most important when you have a geographically diverse set of clients that you're trying to distribute your content to. So performance is incredibly key. Up on the slide, we have a few things in terms of, if you look at 100 milliseconds, that's the limit in terms of users feeling that a system's acting responsively, instantaneously. You'll see that's built into a lot of UX design in terms of when do I have to start showing feedback to user when you get over a certain threshold. 1 second is that limit where a user's flow of thought, starts becoming interrupted, and then 10 seconds is where you start losing a user's attention to their focus on your dialogue starts disappearing. Now, if we bring that into applications that you're building inside of Azure, we look at kind of two examples of statistics. So if you have a website that's taking longer than 3 seconds to load, a few years back they did a study, and what they were showing is like 57% of people will abandon your website. I think this was about a study about 2 years ago, and so imagine that with this more responsive web design, that's probably a higher value now. If we look at video delivery, if it takes longer than 7 seconds where you're buffering for longer than 7 seconds, you can have up to 80% of people who are just abandoning and going somewhere else to watch it. So it's incredibly important that you have fast and good performance. So a few slides just to kind of do the brief. What is the CDN? Why do we care about CDN? So if you're delivering content from the edge and you picked an Azure data center and you put all your content in Azure data center, your clients are all going to connect in. There's not, regardless of where they're coming from, if you picked a like US West or US East data center and they're coming from Asia, they're going to have a long path they're going to come in. There's no real optimization for that latency. And a single data center can be a good solution if you have a limited number of users coming in, so you're not having thousands of concurrent connections, and they're all geolocated around where your data center is. And those are solutions. That's a scenario where, in many cases, you don't want to put a CDN. Putting a CDN there can actually slow down the performance. You can add an extra hop in place. Now, if we look at a kind of a, this is just a representation of a kind of basic CDN POP infrastructure. So the POPs are a point of presence. That's where all your caching goes to. And this is illustrating the one that's close to the Azure Center is just a mid-tier cache. And so when clients connect in, they connect to a POP that's going to give them the best performance. It'll go to that mid-tier cache, and then it pulls from the data center to go. And now content is cached out towards the edge. And in this scenario, I am looking at everyone's watching the same piece of content. You have clients that are coming from across the world. Now, as additional people connect in, they're going to get the value of the content already being on those POPs, and it's going to be much faster and distributed. And this is where you get your performance and your scale capabilities from the CDN. So Azure CDN, as I mentioned earlier, it's a multi-CDN service. We have both Akamai and Verizon. Verizon has been there for a few more years than Akamai, so there are differences between the two in terms of capabilities. We're very quickly trying to even those out so that when you come and you choose your CDN, you're not worried about the types of features that are across those, but there is a difference today. So as I said, with a CDN, you're getting that massive scale, the high performance of security. With Akamai and Verizon, these are the two largest CDNs in the world who have worldwide coverage. You're getting the broadest coverage that you could across the world. One of the core things to point out is around, we provide a rich set of analytics, APIs, and developer tools. And what we've done is we've actually unified that experience across Akamai and Verizon. Typically, when you're setting up a multi-CDN solution, you're having to deal with differences across those. You're seeing different analytics, you're seeing different APIs. If you wanted to purge content, you have to figure out how to purge it differently. If you're using Sidexis, they have built-in integrated ways to purge, but each one of them is slightly different. The syntax for how you purge is a little bit different. If you want to do a wildcard purge versus an individual purge, it's a little bit trickier. If you want to set up TTLs differently across this, you got to understand the nuances of that. And we've unified that experience so that when you're setting up you choose either Akamai or Verizon as the CDN infrastructure that's in place. When you use APIs, they're the same APIs. The only difference with those APIs is you're basically picking the provider you're going to use for that API. But when you purge, when you go set your caching logic, when you go do things such as I want to set up my endpoint, I want to set up my domain, my origin for that CDN endpoint, it's the same experience you have in place. So CDNs and why multiple CDNs matter. It comes down to the internet's a very, very messy place. I'm going to spend a few slides walking through this and illustrating just how messy and complex the CDN is. So congestion can come and go. I always like to talk about my favorite example wherein there was a lot of news reports earlier this year around someone wandering around, I think it was San Francisco, and cutting optic cables. And I don't know if anyone ever caught him, but you just can't control things in that last mile. In some cases, you do have that control. Other times, I don't know what someone's doing out there. The other really interesting point is around micro outages. So we think of micro outages as outages that are very brief, so they can be from a few seconds to a few minutes. And the critical thing about micro outages is that they happen in such a short period of time unless you have an automated solution to deal with that micro outage and move your traffic somewhere else. By the time you're aware of it, it's too late. And they're constantly happening. We'll show some examples of that. One other piece about the performance is that for any CDN that you took, if you took a single CDN, you start looking geographically, there's always going to be some CDN who's better in a different geography. If you go drill down into the individual ISP and take a look in terms of their ASN and see what's happening, there will always be someone who's slightly better than someone else there. And then if you actually drill down into the ISP network, so if you're looking at a mobile versus non-mobile network for an ISP, you can see some big differences. One of the ones Pete and I looked at was around Brazil recently, and it's a big difference. It's like certain of those ISPs, one CDN is dramatically better than the other CDN. To get the best performance, if you were in Brazil and you're going across both mobile and non-mobile networks, you would need to use a multi-CDN solution in place. So the final kind of piece on this slide before we drill into some examples with Pete on to illustrate the messiness of the CDN is that the CDN's performance is never static. It's constantly changing, and there's not complete control from the CDN in terms of the available latency or throughput. It can be controlled to an extent, but as you start getting down towards, pushing down towards that last mile to delivery for the clients, there's less and less control that's in place. So Pete, this is the Sidexis Radar Live slide that you have on your website. Walk me through what we're seeing right here.
So what you're looking at here is a representation of a live site. So you can actually go to right now or after this talk to live.sidexis.com, and what you would see is something that looks identical to this. And What this represents is the micro and major outages that are happening around the world in real time right now. For Sodexis to be able to route traffic to the best performing CDN, they have to measure. And the problem is on the internet, as you all know, there's over 50,000 ASNs, right, that make up the internet, all the little subnets that make up the internet. And so to get measurements from each of those 50,000 networks out there, you have to have lots of measurements. And we've got about 7 billion measurements a day from the endpoints, right, from the endpoints to every one of the CDNs. And, you know, Anton talked about 2 different CDNs that Microsoft uses. There's actually over 40 global CDNs that are out there. Some of them are regional. They specialize in China or Russia. Some of them are global, and they all, as he said, they all have various strengths and weaknesses. Some of them have great throughput. Others have great latency characteristics in certain regions. Some are paired very well with certain ISP providers and not so well with others. So what you're seeing here is each of the little explosions is actually an ISP, a network. And what it's telling you is that they're having a problem, either a latency, a throughput, or an availability issue, trying to get to a certain CDN from that network in the world. You might ask yourself, well, how the heck do you get 7 billion measurements a day? That sounds like a pretty big number, and it is. The way we did it is we've created a community called the Radar community, and it's RUM. How many people have heard of real user measurements? RUM, not the drink.
They're both good.
If you've been in Atlanta all week, maybe you've had both. But anyway, the RUM, the real user measurements that we use have been implemented in over 1,000 websites, right? So if you read Bloomberg this morning, the bottom of that page, there was a little piece of JavaScript that woke up and started taking measurements of Akamai, and measurements of Limelight, measurements of Level 3, and measurements of all the CDNs out there. And what we're measuring for are 3 things: latency, throughput, and availability of all the CDNs in the world from every ISP in the world, right? And that's you know, why you get to about 7 billion measurements. It took about 5 years to get that many websites deployed. And we've got some really large ones. I mentioned Bloomberg, LinkedIn has deployed the tag, Tumblr. So we've got a number of very large sites and then a long tail of other sites. But it's really important to not only have lots of sites, but lots of sites in various verticals and in various geographies so that you get full coverage of the internet. We get about 600 million sessions a day, and as I mentioned, from virtually every network in the world.
So the really cool thing about this is you can go on to Sodexis. I think it's
live.sodexis.com.
And so this is we just have a loop. I think I set it up. It's like 3 or 6 seconds, just looping through, so we can show it from here easily. But you have the ability to scroll back historically. You'll really see how messy the internet is. You can filter out different pieces. You can actually drill down and see where for one of these. For one of the issues, like who is it? Who's the ISP? Who's the CDN? Who's the cloud network where you're seeing issues on?
On average, I just throw this in. On average, any particular CDN from around the world, we'll see over 1,000 micro outages to that CDN a day. Now, that micro outage just might be a big spike in performance or a drop in availability or a diminishing throughput for 5 minutes, right? And it may not even be the CDN's fault, right? It may be the congestion on the ISP, but at the end of the day, it's affecting end users, right? And that's, if you're building sites, this was already mentioned, but it's a super important point. If you're doing streaming video or you're building sites, people bail if they hit bad performance. So that's a really important thing to keep in mind. What you're seeing here is sort of the argument for multiple CDNs from an availability perspective. And again, if you have a single CDN and there's a micro outage that drops your availability to 50% or 30%, which realize what it means. If you go to 50% availability for 5 minutes, that means 5 out of every 10 requests to connect to that CDN are just rejected, right? It never gets there, which means your page load time plummets because it's retrying over and over and over, right? So the way you get around that is by federating in this case, 3 CDNs together to create 100% availability. Availability is incredibly important, and it's an under-realized important, actually. A lot of people talk about latency and throughput, but just raw availability is super important, and we usually have that as a primary check in most of our algorithms for load balancing.
So we're going to spend the next few slides going through. We're going to start with France first and give you a view of the world as we start from a higher kind of geographic level, starting from France, and then we'll drill down into New York and look at kind of the differences. And what we're showing here, we pulled up, so it's Akamai some of these are a little bit hard to see, but so we have Akamai CDN, we have the Verizon, and then we've layered in CloudFront and Level 3, and I'll let Pete walk you through.
Sure. So this is all from a 48-hour period, and this is right out of our portal. So you can go to the Sodexis portal, you can log on, you can create an account, and you can actually see this data. The data's free, and that's one of the draws that we have for why people deploy our tag so often is because we give away a lot of really valuable data for free. So this is from a 48-hour period of 4 CDNs compared, and again, this is latency, right? So lower is better, right? So in this case, what you see is I'm not going to name CDN names because, like I said, I've been in the industry a while and I want to stay in it. But I did list them on there. But you can see one CDN is doing dramatically better than some of the others, and then you've got one that's a real outlier at upwards of 60 milliseconds. And this was just in the country of France, right? So if you're talking about in France, all these measurements were just in France. 60 milliseconds across France is not very good, right? We often can get 40 milliseconds across the United States. So in France, it's quite a bit smaller, obviously. Now let's take the exact same 4 CDNs and look at what it looks like in New York City, or actually the state of New York. Same exact time frame, same 4 CDNs, dramatically different, right? And so what this is intended to convey to everybody here is that no one CDN wins everywhere, right? Geographically, CDNs are very different in how they perform. Akamai is awesome in certain places. Edgecast is awesome in other places. And the only way to get the best of both is if you can intelligently federate the two together and take advantage of where this one's the best, use him, where this one's the best, use him.
And when you hear Pete saying Edgecast, if you weren't aware, so Edgecast,
I'm sorry, yeah.
Some background, when we first started working with Verizon, it was Edgecast, and then Verizon bought them up in, I believe it was like, I'm trying to remember the exact date, it was end of 2010
maybe?
No, 2013.
13,
so,
okay.
Yeah, it was.
It's all a haze to me.
Yes, a lot of haze. So, but you'll see it if you go to Sodexis, you'll see some of these still have their kind of historical backgrounds. You'll see, I think Verizon still shows up as Edgecast, small or large or something like that. I simplified it so it's clearer for you, so it actually shows up in Verizon here. But when you pop over, you'll see slightly different names in place.
So you saw the difference between 2 locations. Now let's take a look at what it looks like for availability. I mentioned availability is very important. You can see here, this is availability, again, in the state of New York. And if you look at where the drops in availability happen, they actually are tightly correlated with the 2 increases in latency, right? So when this availability dropped, latency went up. And I mentioned earlier, it's important to understand availability has a serious impact on both latency and throughput. But as you can see, again, in availability in New York, in this case, Verizon took a pretty big dip. Again, if you have bought, how many people have bought CDN services before, right? How do you understand SLAs and so forth, right? So the SLAs you typically get with the major CDNs are all 5 nines, right? Who's heard 5 nines? 4 5 nines, right? Well, if you've got, as you can see, if you can see this with a small font, but none of them are 4 nines, right? None of these 4 are 4 nines. It turns out when you measure things using real user measurements, and this isn't to call the CDNs liars, right? That's not what I'm saying at all. It's just that when you're using real user measurements from endpoints, you never get 5 nines, right? It's always going to be less than that. And because the CDNs, what they do is they measure SLAs from within their own network. So they're just basically saying, as measured by us, we've got 5 nines, which doesn't really help your end users a whole lot.
And one of the things you're seeing is these dips, as you're seeing these dips in kind of availability, we could layer on 6 or 7 or 8 additional CDNs, and we might see that in certain cases, there's a certain CDN that will even it out and you get the higher availability. But there are cases where you're getting a big bottleneck coming into a country or a region, and there's nothing you can do, and it's just like everyone's seeing that dip that's coming down.
Yeah, it's true. If we listed 40 CDNs here, for sure you would have one of them that just had a straight line across, across the 98 or range where it wasn't affected in this way. It's indicative of peering relate. Yeah, these 4 are probably in similar POPs, probably similar data centers and POPs. Whatever congestion is happening right there on the left-hand side is probably it's affecting all 4. And it's probably, if you were to drill down in a minute, we will drill down into a network, a singular network, to see which one, to see that once again, it's even different at the network level. But it's about peering, and it's about where the POPs are geolocated. But it's more about peering than the POPs, to be honest with you. When you're limiting the measurements to just the state of New York, again, it's really about the peering.
And if you look at a large network like Comcast, you can have multiple inputs into their network, and everyone's going to, there might, because of the relationship they have with Comcast, they might have a different input into that. You saw that a few years back where Netflix and Comcast were kind of fighting around, how traffic was getting inside of there, and there was pushback. Well, if you worked with us, we could come you through a different path. So it's very much peering and relationships, and then it can dramatically change. That ISP can over time can change that
Absolutely.
relationship and can route or can throttle the traffic that's coming through.
Absolutely. Yeah, please. We can talk about that. Sure. I did not intend on it, but using Codexis or just in general? Okay. We can talk about that. Yeah, I'll be happy to, towards the end if that's okay.
Yeah, we're going to leave enough time towards the end to pull up whatever questions people want.
So again, same time frame. Next slide. The same exact time frame, and instead of availability, what you're looking at is throughput. Again, throughput. You want more throughput, right? So the higher measurements in this case. Looks like between 10 and 12 meg essentially, and looks like level 3 in fact is the best. So if you're streaming video in New York and you're looking at which of these three, because video is extremely throughput sensitive, right? That's if that's your use case, then really what you want to key on is throughput and availability. If you're doing websites, lots of small objects, maybe it's more about availability and latency. Right, but in this case, this particular CDN was the best in this geolocation. If I took a screenshot of if I went to the tool now and said, okay, let's look in California, completely different, right? And now, again, I would urge you to, I'm sorry, I would urge you to go validate what I'm telling you yourself, get the account, go look at the data, because this is all just data driven.
Now, one of the things to point out, since you're saying level 3 is the best.
No, just right here on this chart.
No, if you look at that final kind of dip down, you'll see that like Verizon, there's periods of times where there's an overlap on
Absolutely.
there. So if we look at, one of the key things we look at performance is that was why we wanted to start drilling down, as we look at the kind of an aggregate level. You're like, well, who's the best CDN in the world? It's like, well, I don't know, what does it really mean? Because it matters where your clients are. As you start drilling down, it's like, where your clients going through? And then it's over time, it's like, well, it changes. And even if if we look at this one and say, hey, level 3 on average is the best, going across this, there are periods of times where a little dip, and that's no longer true.
It's absolutely true. And averages lie, right? Looking at averages, you really have to look at the time-based data, and what it'll tell you is exactly this, which is it's going to cross, it's going to change, both over time, in geography, and obviously if Farmer John cuts with the backhoe cuts the fiber to level 3, you have a major availability, and that has happened, by the way.
My favorite stories were when we were setting up our data center in Brazil. Of like, we had an outage, and like, what happened? It was like someone drove across the road and the fiber optics were strung, just like telephone wires, and just pulled it down. So it's like, it depends on the country and where you're in. So it's not just someone digging something up. It can be just because of the infrastructure.
It used to be squirrels, right? That used to be back in the early 2000s. You'd hear of squirrels, all the because they hang. There's line fiber in the air here too. It's not just Brazil. And this last slide is the exact same time frame, the exact same location, but on a different network, right? And now look who's winning, right? In a different way. But so it does change, and I would again urge everybody to go look at the data yourself, because that's the important thing. One last thing is there's a huge variance in mobile networks, right? How people on mobile networks are experiencing a website or a video, and people on non-mobile. And we have a next slide to actually indicate what that looks like. What I did here was I took 6 CDNs and I looked at their traffic across 3 mobile on the left-hand side and 3 wireline on the right-hand side, and did a statistical distribution. As you can see, the statistical distribution on the wireless providers is dramatic, right? Some people get 100 millisecond kind of response time. Others are getting 350 milliseconds, which is, that's horrible, right? I mean, 350 milliseconds, your page might be, or your app might be 6 seconds, 8 seconds, 10 seconds to load, which most people just go boom, delete, and they're out of there. So something to consider as you develop your sites, as not only is it important to federate CDNs for your wireline but it's perhaps even more so on the wireless side.
And that example I gave earlier on Brazil, what we actually looked at was looking across Verizon and Akamai. What we saw is, like, if you only picked one of those providers in Brazil and you had a distribution of your clients who are going across both wireless and wireline networks, you were kind of losing out. It was, I think it was somewhere like, depending, I forget which the numbers were, but it was, you know, like 70 on the wireless side, it was like 70% was favoring one of the CDNs, and we went to the wireline, it was kind of almost the exact reverse.
Right.
And it changed. And so when I think about it, it was like the 70%. It's like it depends which ISP you went across. Where some of the mobile traffic going across, it was 70% of the traffic on a set of ISPs was better, but on the other ones it was better on the other CDN.
Right.
So it's a complex, messy world out there. So this is a kind of a transition as we go into, well, how can I control it? Is there ability to control it? And so one of the things we look at is around, you know, the level of control I can have if I am just in, the, you know, from the origin going out to the initial carrier before I go all the way down to the ISPs, where you're seeing somewhere in the range of about 25 or 26% of the latency. That's what you have control over. Now, as you go down through those ISPs to the, you know, the peerings between those, somewhere in the range of about, it's about 74% of that latency you don't have control over if all you're doing is controlling it from coming out from your data center. And on the mobile side, it's even worse. It's like about 97% of that. Now, you can control it. You can control it by actually, as we were starting to allude to and show, is you can put a multi-CDN infrastructure in place, and that allows you to control it to an extent, but not everything. You see that top woman at the top, she's kind of lost her connectivity. If there's an issue that happened with the ISP, or let's say, you know, in some cases, not even the ISP, it's her home network. Right. It just went crap, or she, you know, something happened on it. But you can dramatically change the amount of control when you actually add a multi-CDN layer on top of it. So, So we're going to step through and walk through the different levels of kind of traffic management. I'll start with the simplest. It's the failover. We used to think about it when we do the Olympics, where it's that red button where you're in a, we'd always, whenever we do the Olympics, we're like, we have deployments in the data centers themselves in multiple geographically dispersed areas. So if there's an issue, I hit the red button and I can move the traffic over pretty quickly. And that's the kind of simple failover. If I set up Verizon and Akamai, I can use DNS to basically put the same CNAMEs on there, and if there's an issue, I go and hit the red button and move my DNS mapping so it goes to the other provider. But it's pretty limited. I mean, it's not going to handle micro outages. It's going to deal with problems where like something completely went offline. And those cases do happen. We saw a case recently. We were dealing with issues in Oman where one of the big telecoms in Oman, like traffic just wasn't flowing through for one of the CDNs, and we had to move it off to another one of the CDNs. And it was, we never completely figured out what was happening, but there was some kind of throttling that was, or some kind of control they put in there that was blocking a set of the VIPs that were coming through. So the other one to look at, and this is actually the simplest one to put in place, and it makes sense when you're in a data center and you want to spread your load across multiple endpoints, is just round robin that traffic across those. Now, round robin, the interesting piece is that it's when you put it for a CDN and you start getting globally dispersed traffic, is it's pretty much random data. You're putting, you know, randomly which one you're going to choose, and so you're randomly going to put one person on potentially a network that has lower throughput and higher latency, and someone else goes on to something with better throughput or latency. You're really not controlling. You're not looking at what the actual performance is. Geographic load balancing, something that's easy to do with traffic managers, has its uses for a limited set of cases. And this is where you're looking at the IP addresses for the user, and then you're choosing which CDN I'm going to use for them. And so the use case, Oman could be one of those, where I basically say, hey, I know this region, it's something just bad happened, let me go put it over there. But the best use case is really when we look at China, is that if you're serving content in China, the local CDNs having POPs in China will always give you the best performance overall. There's some cases where on the edges of the network where you're serving, and we've actually seen with like Verizon, sometimes they'll get better performance coming into the country when they come from Miami, which doesn't make sense. It's like farther away, but it's actually a connection. These connections that are going inside of China get highly congested. So really your best throughput in China is there. So it's not a bad mechanism if you in a limited set of cases. Now where you start getting into that control that we've been talking about, the kind of control you get with Sodexis, is when we start looking at performance-based, whether it's synthetic or run-based measurements. So I want to talk a little bit about synthetic measurements. So these are things, if you're using Gomez or Catchpoint or something like that you typically see, where you have an agent that's sitting, and it's the CDNs will purposely, they know where these agents are running from. They tend to be running, you know, inside of an ISP. So they're putting them. So you're basically testing performance in that backbone between down to the ISP from the CDN's POP, and they're good for seeing overall kind of what are the characteristics, the behavior that's happening. But you can also get a lot of false positives that come out of this. You don't get enough data. You don't have enough agents that are set up enough. You're not getting billions of measurements. You're not testing across all the inputs that can come in. And so when we've seen like teams at Microsoft that have used this, initially when they onboarded the CDN, there's always this like, hey, I'm seeing issues in this location. I'm like, well, where? Which country is it? Well, that's a country like if it's India, where it's like, well, you know, it's the kind of the conditions are pretty variable. They go up and down.
Yep.
And we've had people who, when they looked at, you know, they were using Verizon initially, and they saw when we onboarded Akamai, it's like, hey, I'm going to put everything on Akamai. It's got to be the better solution. And they took a look, and it was like, it wasn't in aggregate when you look across time. So RUM, as Pete was talking about, this is all based on real user measurements. And before we dive into what RUM is and kind of the characteristics on it, I wanted to do a quick walkthrough in terms of, with Azure CDN, what does it take to set up and do the simple failover? And so the example I'm going to do a walkthrough on is we have a CDN endpoint that's been set up. I already set up with Verizon. We're going to copy that endpoint over onto Akamai. And the kind of cool thing about this is it illustrates just how simple it is to go and set an endpoint somewhere, and the consistency and unified nature across those APIs. And I can show a quick example. I bought a very cheap domain from GoDaddy, dustydog.xyz. And you can just go, once we have this set up, we go up to GoDaddy, and I can basically say, you know, flip the DNS and point it over to the other CDN provider. So let me move over to my demo machine here. And so what I have set up, in that previous slide, you can go there's a PowerShell script that we have that you can go and take a look at. That's in GitHub. And let me just scroll down to the bottom. So I've actually simplified it a teeny bit. So I've set up this endpoint that's called Ignite 2016. There's an array here that's going to take, and I've only set up one CNAME, but the script, if you have multiple CNAMEs you want to set up, you want to move them over, we'll handle that. If I scroll down to the guts of the script right here, into here, so right here what we're doing is, and I'll walk you through with the portal also briefly to illustrate some of these concepts, but we have this idea of a profile. A profile identifies the provider, whether it's Verizon or Akamai, and the SKU that you're using, and it's a container for the endpoints. And the endpoints are essentially, think of them, their configuration for the CDN, and it gives you back a domain name. So in the case of our example here, we're going to take all the info from that existing Verizon endpoint. I'm going to copy it over. I'm going to copy over the host headers. I'm going to copy over the path of the origin. I'm going to copy over, if you put on particular compression files you're going to compress with. And these are all the basic pieces. The setting up, copying over whether you turn on HP or HPS, what the port is that you set up for those. And then at the end of the script, it walks through my vast, huge list of custom domains. I set up the one. It will go copy that one over. So let me go run this script, and then we will take a quick look at the portal. It takes about I think about a minute for it to complete. Let's run this. So it's off running. Let me go move over to the Azure portal. And so I'm logged into the Azure portal, and if I go down and click on CDN profiles, you will see, actually, it already started creating it. So this was the one that we have right now, is Ignite 2016. The Ignite 2016 standard Akamai, I'm going to give it a minute to finish. It's only going to have part of it in place. But if we take a look at what's on the Ignite 2016 one, this is the one that's running on Verizon. You'll see that I have two different endpoints set up, and the one that I'm going to use is the one called Ignite 2016.azureedge.net. So that's the URL that if you were accessing content from the CDN, you would use. And if you think about a CDN, at its guts, it's pretty simple. It's a reverse proxy. You point to an origin, and let me click on this, and I'll show you what we're pointing to on this one. And we're pointing to, in this case, we are pointing to, you can see up here, so it's pointing to, I just created a storage account. So it's pointing to a storage account in Azure. So you have a host name. You could directly go to the host name, but because it's a reverse proxy, you're never going to see that origin host name. You're just going to see that domain name from the CDN. And so when requests come in, and if the CDN POP doesn't have it, it goes back to the origin, and that's, in this case, it would be the Azure storage account, and it will pull it back from them. And then you can see what I have set up is I have set up a host name of cdn.dustydog.xyz, and when the PowerShell script, which is still running slightly, finishes, you'll see that it's set up on the other one. So let me go pop over and take a look at how we set up the CNAMEs. And so if I look at, so this is what I have set up on GoDaddy today. And there's two ways to go set up the CNAMEs. One of the critical pieces is when someone sets a CNAME is, in many cases, they need to be able to set it up so it's done in a seamless manner. So the way to set it up when you first enable it, and if your CNAME was initially pointing to your origin, you would not want to do what I'm doing right here, which is essentially I am saying, so this is my friendly domain name, so cdn.dustydog.xyz, and I have it directly pointing to this is the endpoint from the Verizon side, so the Ignite 2016. If that CNAME had been pointing to my origin, if I moved it over, I'd have a period of downtime as I moved it over. So what we allow you to do also, you can do that CNAME mapping and the verification with something called CDN verify. So you put CDN verify on the front, and let me go back a little bit just so you understand why. When you set up a CNAME on Azure, and you'll see this pretty consistently across services, we go verify that you actually own that CNAME. And the reason we do it is to prevent someone from kind of stomping over or taking over. So if someone else, maliciously or just because they were just kind of testing out and typing things in, had taken and said, hey, I want to set the CNAME up, if we didn't verify, someone now would have registered that CNAME when you came in and tried to use it, it wouldn't be available for you. So every time you go and put a CNAME in, we'll go back and check either that you have a direct link for that CNAME. So in the case for Verizon, we go and check when we set it up, we'll check and see, is there a CNAME mapping from cdn.dustydog.xyz to the actual endpoint domain name for the CDN. Now, to move it over to the Akamai one, what I'm using is I'm actually putting in another subdomain, cdnverify.cdn, and doing the same thing with the endpoint. I set up the endpoint to be cdnverify. And then the endpoint name. And so if I look over here, our PowerShell script is finished. If I go back to the Ignite site, if we go over to my other endpoint here, you'll see that the second endpoint has been set up. It's running. If I click on it, it should have also captured and it's captured all the host names. So it's a very, very simple example. And one of the things to understand is when you look at the Azure portal, all the capabilities for the CDN, those are all provided by APIs. Everything that we build from the portal, it's also available via public APIs. Let me move back to number 5. So I'm going to have Pete now step us through. So that was really the simple piece. And one of the pieces I didn't point out is one of the things I learned when I was setting up GoDaddy was the lowest I could set the TTL was 10 minutes. So if I did have an issue with the red button, and we can probably call them and get it set down, but the default was 10 minutes, is like just illustrates like trying to do. It's like the amount of time that you can actually change your TTL can be pretty limited. And so 10 minutes to go deal with an issue in some cases might not be that big of a concern. But if something was on the floor, you would want to be able to react in a much faster period of time. And so I'll let Pete walk us through what it means from what we're doing RUM. And do you want to drive or you want me to? I will.
And before I do that, let me back up a little bit because I think it might be a little helpful to kind of talk a little bit about control, because there was that one slide we had about how do you control what's outside your firewall, right? And the primary there's a couple of mechanisms. One is if you're inside of a player or CMS, you can control things directly from there if you have the data. And the other way is DNS, right? And that's the primary mechanism that most cloud-based global traffic management systems are using, is they actually they use DNS. Now, it's not a perfect mechanism, right? There's all the TTL issues and so forth you have to deal with that was alluded to here. But and to get around that, you can actually use an API, right? So Sidexis supports both a DNS-based load balancing system as well as an API where you can make a request for what's the best performing CDN right now from this ISP and this geolocation. It'll return that. But in our examples here, we're going to primarily talk about DNS.
And one of the reasons that can be critical in certain parts of the world, you might set your TTL low. So like go down, hey, I want to get down to 10 minutes. It's not always it's not, like I think in the Middle East we've seen where sometimes I set a low TTL and I go, look what's happening. It's like, they just changed it up to an hour. So
yeah, I mean, most places in Europe and North America now are respecting low TTLs, but not everywhere does, right? And it's a problem. I think over time that'll continue to evolve in the right direction because more and more infrastructure is being based on being able to move things quickly, rapidly using DNS. So I'm gonna, as we said, we're gonna shift now talking more about control, but to understand how you would do this, I'm gonna, still talk a little bit about the real user measurements and how we get those measurements because that's an important aspect. So if you look at this is an example that we have of Rachel here in the United Kingdom, and she's on British Telecom, right? And she wants to go out and read The Economist. Well, it turns out The Economist has our RUM tag deployed. right? So there's a little radar tag there. Now, it doesn't have to be the radar tag, or it doesn't have to be the Sedexus tag. You could deploy your own RUM, and many, many of these clients do, right? In fact, there's a whole industry of tag management companies that manage all the tags that people put on websites. I think by last count, someone like CNN.com might have had 300 different pieces of JavaScript on their site. So that's a whole problem in and of itself. But we're yet another tag in many ways. And so in this case, Rachel goes and reads The Economist. While she's reading, the Sedexus tag wakes up and it says, I'm going to measure something. I want to measure CDN1 and CDN2. And it does those measurements. It finds out CDN1 is 12 milliseconds from BT, and CDN2 is 999 milliseconds, which is not good. So so that's great. That gets sent back to our global ingestion system, which we essentially update all of our points of presence about every 7 to 10 seconds with this radar data. So the data is very fresh. And so what we found here is that from this geolocation, from this network, one CDN is dramatically better than the other. And now she knows it, and it's clicking through. All right, so now John, who is in the same geolocation, on the same network, right, in London, he goes to connect to Microsoft, and Microsoft is using Sedexus. So the Microsoft site wakes up and it goes, hey, which one of these two CDNs should we go to? It asks Radar. Radar says, oop, I know which one. Boom, and it comes up. That's in essence how our system works, right? I mean, it's very highly simplified, but that's what's going on, and it's going on billions of times a day. So I want to talk a little bit about a client that we have. This is a particular client, as a gaming client, and I want to show you what the decision report looks like. We talked a minute ago about what Radar looks like, right, which is our RUM data, and you can see, in different geos and different networks, what the throughput and availability. Let's take a look at, for this particular gaming client, what their decision report. So what you're looking at is 4 different CDNs, right? And these 4 CDNs are this is worldwide traffic. So, when measured, and again, it's an average, right? Anytime you're looking at worldwide traffic, you're getting a very broad brush, right? So you see here in this particular case, the decisions, Akamai and Highwinds are both getting a lot of the decisions, and so the other 2 are getting fewer decisions. Let's take a look at what this looks like when you drill in to the little country of Belgium, right?
And Pete, when you say decision is...
Sorry, DNS decision. So in other words, the way Sedexus works is it's essentially a CNAME, just like a CDN is, right? So this particular client, when someone goes to download the game from Roblox, what they're actually doing is they're calling Sedexus, and Sedexus is responding with, oh, that's this guy right here, from where you're at, this guy right here is the best CDN, and we're handing them back the CDN CNAME. Does that make sense to everybody? Yeah? Okay. So in this case, what you saw before is the decisions, broad averages of the decisions worldwide. In Belgium, you can see it's quite different. And what you start to see when you drill into, and what's interesting when you drill into specific geos, and I spend a lot of time in this data, so I'll point this out, but you see this is the diurnal. What you actually see is nighttime happening, right? So people in Belgium are actually, they get tired and go to sleep like everybody else, and that's what you see right there. And then the day picks up, and all of a sudden, more decisions are happening. But what you also see here, and that's more important, is different winners and losers, right? That's what you, and again, that's emphasizing that geo and network have a huge impact on who the best CDN is. Same time frame, but over a single network, right? So now on a single network in little small Belgium, you see that, again, vast differences in which CDN is getting the traffic and which isn't, based on, again, performance. And lastly, what we refer to as the minute view. And all these are just screenshots, by the way, out of our portal, right? So again, you won't be able to see these screenshots unless you actually start using OpenMix, using the load balancer. But the other stuff I saw, which was just the global traffic of the community, you can see all that. But what you're seeing here is very interesting because it's 1 minute intervals, right? And what's most interesting is that it really harks back to the messiness of the internet, right? You can really see the ups and downs of these decisions in real time at 1 minute intervals, and how many decisions are going back and forth. And you can see, again, 2 of the CDNs in particular are really winning a lot of the decisions in a very specific geo. So I wanted to spend just a second talking about the overall architecture, because this is an important part of, in particular, cloud. But we don't just load balance across CDNs; we load balance across clouds. So the radar, we've talked a lot about that, which is the real user measurements. OpenMix, which is our selector engine, that's the engine that allows you to DNS-based load balancing between different CDNs or clouds. But on the left-hand side, what we have is what's called Fusion. And what Fusion does is we've integrated with a variety of application performance monitoring tools that lets you, and you can ingest that data as part of the decision. So for instance, if you're using New Relic, or you're using Catchpoint, or any of those type tools in monitoring your own web servers, you can take that data and ingest it into the decision. So you can not only say, hey, I want this to go to Azure East, if you can say, Azure East or West, or you can say, I want it to go there, but only if, the servers are actually have an appropriate amount of utilization. So it's an important point. Most of our really bigger clients use Fusion, but some of them use it to actually do synthetic monitors of CDNs, right? That's one very valid use case. Another is, again, in the clouds, and we haven't talked a lot about clouds here because this talk's really about CDN, but from our perspective, load balancing is load balancing. It doesn't really matter if I'm pushing traffic to a web server or to a CDN. So, and I think we were going to do...
Yeah, we wanted to close out and leave some time for Q&A. We'll do a quick kind of walkthrough in terms of at least the types of code samples that are there you guys can go dig into on the Sodexo side.
Right, and if you go to, and the site we're going to show you is called developers.sodexis.com, and it's a GitHub. It's a very simple GitHub, and the way our selector engine works is it runs your script. It runs a piece of code that you can either select out of our GitHub or write yourself. It's JavaScript, and we have probably 20 or 30 different examples in here. You're going to want to take yours and customize it for your situation. Use your CNAMEs for your CDNs. By the way, just to be clear, we're not a CDN, obviously. Sodexis is not a CDN. Nor do we resell CDNs, right? So, you're going to have your own relationship with Akamai or Verizon or whatever other CDNs you would choose, just like you'd have your own relationship with Azure. So, but again, these examples are, I'll just run through them real quick. I think the one here that I like to look at most is optimal round trip time. Wasn't it up a minute ago, or?
I had it there, maybe towards the top.
Optimal round trip time, yeah. So if you take a look at this one, it'll give you an explanation of what what it's used, how it's used, and then it gives you examples of the codes. And essentially, without going into a ton of detail, because I don't feel like, you can get this anytime you want, but essentially it's going to just, this simple example selects the best CDN that is the lowest latency CDN. There's other examples in here that selects the lowest latency CDN, but only if availability is over 80%. There's other examples that choose the highest throughput CDN. There's other examples that choose the highest throughput CDN, but only if certain other conditions. We also have lots of examples that are about cost-based routing, right? So you can do cost-based routing. Part of what Fusion gives you is it allows you to pull back your CDN usage. So how many people here have ever had a bursting situation on a CDN, right? So all of a sudden you get the bill and you had a major overage and you had to pay a giant burst cost. We can help control that by as you get closer and closer to where you will start bursting, we can start routing traffic away, as long as performance is within 10 or 20%. So we got examples in the GitHub of those kind of scenarios as well. So I think I'd almost rather go and try to talk a little bit about the RUM and how you do that. So
let me and so
yeah, please, yeah.
I'll just wrap up and then around, and we can jump into questions around. We looked at Pete, when Pete's talking about bursting, it's something you don't have to worry about on the Azure side.
Well, it's a big advantage.
When we're looking at Verizon or Akamai, those are integrated experiences, so we make it a lot simpler for you to be in there. One of the things, and the reason we have Sodexis up here right now, we're looking at is, so today you have to pick the individual CDN you use in Azure. You have to use a solution such as Sodexis if you want to get that traffic management in place. We are planning on building an integrated traffic management solution that allows you to do it across the CDNs that won't be available sometime until next year. It may be built on Sodexis, maybe built on something else. We're still looking at what we do there. So, but that's one of the core pieces. So today there's the extra piece you need to put for Sodexis. Long term, we're looking at how we can make it a simplified experience so you can just say, hey, just pick Azure CDN and you do the right things for us under the covers. And then I just wanted to, because they want us to walk, oops, let me go back to, flip over to number 5 here. You guys have probably all seen these free resources, so I'll skip past that. And then, you know, please evaluate the session and give us feedback, so next year when we come here, we can have an even more awesome session. And I want to open the floor up for any questions that you guys might have.
So let's start with the one that, because I think what you're asking is how would you deploy, how would you do RUM? And I think the answer is two parts. One is there are companies like Sodexis, like SOSTA, like others that have RUM tags that you can deploy on your site today. So for instance, if you, you know, I'm here representing Sodexis, so I'll tell you what you do with Sodexis. You'd essentially go on, create a free portal account, take the little piece of JavaScript tag. In fact, we had if you don't mind going there real quick,
Yeah, sure.
Is that 8?
Yep.
I'll show you one. But essentially, you would take the piece of JavaScript and put it on the bottom of your site, and then within minutes, you could start looking at how your traffic, what's the page load time of your traffic, what is, and that's because of what Sodexis does, we give that away for free. The other answer is you could, and so that's a service, right? That's RUM as a service. And there's other companies that do that. Some of them, because other companies aren't necessarily doing global traffic management with the data, they may charge you money for it. The other way you would do it is you would go, and there's open source, products like Boomerang that you can download, and also the same thing. The difference is, and it really depends on how big your website is. If your website is reasonably small, if it's a personal website or something like that, then getting that information back is not a big deal. You have to fire up some beacon servers that will accept the responses and so forth, and then you have to build a way to report about it. But again, it's not terrible. If you're a large website, if you're getting 100,000, 200,000 page views a day, that becomes quite an undertaking, right? You then have to have an infrastructure person who knows how to build that kind, an Anycast network that can accept that many responses, and it becomes a service that you have to build, manage, and own. So obviously, I would recommend using something like Sodexis as a service, but there are multiple ways to do that. Does that make sense? Yeah, absolutely. Yeah, again, and I would urge you to go to Sodexis.com, pull up, create a free account, and the worst thing that happens is a salesperson might call you, but you can just say, don't call me ever again. I won't call you. I promise I won't. It won't be me. Are there any other questions?
You're all
It's day 5.
thoroughly chilled.
It's pretty chilly in here. It really is. Well, it's the 5th. It's Friday. Oh, you got one question.
Go ahead. Yeah, definitely.
But until then, you should think about Sodexis, right?
We'll make it simpler. I mean, that's the goal. It's for us. It's not just about having there as a checkbox. It's trying to make it simpler.
No comment, but yeah.
Never as simple as that.
No, it never is. I'm sorry. Say that one more time. Oh.
We always leave it in an option. I'll leave it at that. So. Uh-huh.
You move on with the new library functions like high standard public content.
Mm-hmm.
And there is announced that there will be an option for private content later on. Will it be well
When you say private content, you mean in terms of non-static or like kind of dynamic private?
Private in the sense that you need a filter to catch.
Oh, in terms of being able to authenticate, getting at it. Yeah, so we'll start with Verizon this year. It's very, very close. Manling, who's sitting down here, is working on that. Just making sure she's awake there. Her head's buried down in her screen. We'll have token authentication support from Verizon later this year. Probably I think about a month away from having that in place. It's actually something that's been on Verizon for a long term. We're just finishing up the final pieces so we can integrate it from our side. On the Akamai side, I don't expect to see token auth until the first quarter of 2017.
No, actually, I wrote her an email, and I got the message that
There she is.
It wasn't a lie.
Okay, so you will also basically move on to Akamai for the SharePoint piece. Because we implemented something at the earlier stage ourselves with an event recruiter,
Yep.
storage, obviously you use the Verizon premium.
Yep.
In that premium.
Yeah, yeah.
We're looking for these filters later on and trying to keep track if you still be on the right ship or not.
Yeah, our number one request we got to finish first before we get the token auth in place is the custom domains with HTTPS. So it's like part of the journey that we have was around basically getting that base functionality in place across both CDNs, and that's one of the reasons we look at like on the multi-CDN side that waits a bit in the background until we get equal kind of balance across both Verizon and Akamai. And it's really critical when it's interesting because we see such nuances that you never expect to see when you're looking across two different providers. We're like, that should be simple to go integrate in. And you start looking at like how TTLs or how headers come back, just things that can be very annoying when you're setting up and trying to get that unified has been a very interesting journey for us. But it's critical for us to get those really nailed down because it's what makes it easier for you guys, where it's like you don't have to worry about that. And it's funny because my background, I didn't mention this, but I spent over 10 years in the media streaming base side of the world in Microsoft. And CDN is a little bit newer for me, and I always like, Manling has a background in CDN, but I always find it good that I kind of come with this little bit of a fresh aspect of looking at CDN, where it's like, my view is that you really shouldn't care about CDN long term. Our goal is to basically make it kind of disappear in the background. When you think about CDN, it's performance, scalability, and what did I miss? My third one, performance. And security. Performance, scalability, and security is like, it should be just something that you can attach to anything, and you don't have to care about the nuances. So if you think about that vision that we have is around, and the kind of the multi-security piece is like, when you set up your origin, you have your workflow, it should really be just a one-click setting where I'm saying, either I'm saying I'm turning on CDN, or just give me that higher performance, higher security. And you see some of that if you look at media services today. We have integration there where when you set up your streaming endpoint, you can go click, and you can basically automatically, when you create that streaming endpoint, it will turn on the CDN for you. And behind the scenes, the host name stays the same, but behind the scenes, we're setting up the CDN for you. We actually set the right compression types that you should have in place. And those are all things that we can do because we own the majority of origins that we have. So we know what are happening on those origins. They're origins, for the most part, that are inside of Azure, and we know that we can make it a much simpler experience.
Having a origin imager, is there any capability of auto scaling depending on the load of traffic?
What type of origin?
Static content, versus content.
So you have the ability, so if are you going across a website or storage or websites? And you're just talking about the ability to scale out the, so look,
Say in the morning,
yeah.
traffic isn't too heavy, so you can scale down there. Going into the evening, traffic pops up quite a bit.
And you're just talking about scaling out the number of origins. So there are, I haven't looked closely at what like in the past few months, but you do have the ability from websites to basically say, I'm going to scale, and I believe they do have what you're talking about in terms of like the time frames in terms of when that scaling happens. So I think that's been in place for several months now. So we can take a quick look. I can go into the Azure portal afterwards and show you. So, well, Depends on your loads, right? Because if you get massive number of loads coming in spread across the world, you can still have
Yeah, you
hits
DDoS.
coming across.
You essentially get DDoSed without it. So
I mean, so the other piece that we're putting in, you saw me in the example where I was talking about, hey, we'll put in a kind of a mid-tier caching example. So that's another piece that we'll have coming in. I don't know if we'll get it before the end of the year, but it's basically say, hey, look, instead of having a large number of POPs coming into my origins, set up in the Akamai case, it would be a subset of POPs coming in. In the Verizon, you can actually pick one or a small number of POPs that come in, so it drastically reduces when you need to go back to your origin for requests. So. Yeah. It's still, 10% can still be pretty huge.
Have you thought about using like a DSA type service? So dynamic site acceleration, actually, I don't know what CDNs you're using, but essentially you could use that kind of service for the uncacheable stuff.
But it's still going to hit. It's still
going to hit your origin, but yeah. I mean, just it would, it's not going to solve the problem of needing to spin up additional origins.
And since Pete mentions the dynamic acceleration, that's another piece that we're working on. So that will be available by at least Q1 of next year. I'm trying to think if there's. Yeah, it's one of our largest customers. They can easily hit. They have. When I looked last week, it was 99.9% cache hit ratio. It's like almost everything's hitting the edge, but they have billions of hits that come in a day. And you take billions of hits, even at 99.9%, that's still a large number of requests that can come down to the origin. If you're hitting like Azure storage, they'll throttle because it's a multi-tenant environment. So, yeah, it's a legitimate concern in terms of no matter what your cache hit ratio is, when it starts getting large hits, you can still get large number of hits on the origin.
There's a question over here.
Yes. It's globally today, so be interesting to hear your feedback if that's something that you need. But it's one of the you choose either Verizon or Akamai, and which region actually gets used is based on with Akamai they're using DNS, with Verizon they use Anycast to go determine which POP is going to serve that content for you. That's our future coming soon next year, where we make it simple for you, where you can basically just say, hey, just give me CDN. And since you're new, a lot of these, and like I was saying, a lot of these concepts, they might not matter to you, and in many cases, they really shouldn't matter to you, because you're like, I just want to use it for performance, and unless, if you're doing something like Olympic scale, then you might want to get into down to the metal to kind of scale things, but most people don't care about that, so. I mean, so if you look at like the breadth of our customers, it's for websites, it's for video, it's for firmware downloads, it's for anything that's cacheable today, and then we'll be adding in support for when you think about, some of the things we're talking about, like the latency concerns. So if you're putting something in a shopping cart, those things you're putting in there tend to be, they're just for that user, that experience is for them, but can you make that faster? And you can. Pete was mentioning like a DSA, which is site acceleration, or essentially it's like it's passed through on the CDN, but what you're doing is you're getting that content as fast as possible in the best path from the origin onto the WAN for the CDN, and then popping out at the last possible moment to the client. No, you can. I mean, if you're just for today, if we're optimized for static, you can. I mean, if you basically say dynamic, in some cases you'll get better performance. But it's not optimized to the extent that you can with dynamic content. So with a DSA-like offering, you can dramatically increase. You can easily see 30% more increase in terms of speed versus, hey, I'm just sending it over the open internet and I have no control over where it's going. So you can do, and there's smarts that you can do in terms of, okay, which POP will actually pull from the origin. That can change over time. The conditions change between the POPs. You can change which POP is pulling from the origin over time based on, watching what those conditions are. Any other questions? We're down to the final 4 in the room.
You got one more? Yeah. You mean which CDN carrier or which ISP?
That was the fun one that we looked at it. There wasn't one that was better. It depended on which.
Yeah.
When we looked at it, it was actually, and so you on the Sodexo side, they have something called like an S curve they come up, which illustrates the kind of as I go across multiple ones, which one's best. And what that curve actually shows you is that there's a percentage of traffic depending on the ISP that's better on one versus the other. But you can easily see where it's like we were seeing. And I don't remember which is which, so I'm just going to throw numbers there. It was like 60% if you're on non-mobile was better on Verizon versus like 40% on Akamai. And you switch to mobile, and you get kind of an opposite in terms of. But what it shows you is that if you wanted the best performance, you want to be using multiple CDNs. They both have good performance there, but when you're dealing with those kind of micro outages and the dips over time, if you really want to optimize it, you can only do that if you have more than one in place. Yeah.
If you want to figure out who's doing best right this second, I can't think of a better place than to go to Sodexo.com. Go look at the radar. Actually, there's come up afterwards. I'll show you.
We had the.
Yeah, what was it 8? You said.
This was this one or the?
Well, just go to. Actually, there's the
More or less.
country
Does
reports.
anybody want a? I have one shirt. It was too big for me. It's a large. One of you
Mine
wants
is
it.
too large as well, so I'm too big, so it's easy. I'm XL, so it's not just large.
How do I get
This was my. I didn't want to throw it out, but it's like a presenter shirt, but I am more of a medium. It's a nice shirt.
That's a nice shirt.
Actually, I guess I'm also more like a medium. So, am I the fat guy?
I'm wearing large.
What do you got? He's got
I'm
a large.
wearing
You guys
large.
are like,
So
they went a little bit.
if you don't want it, I'll take it. But
From your size.
all right, there you go. There you go.
Cheers.
Yeah. So if you go to here and go to these country reports,
Yes.
right? You can go here, and this is just without even getting a login. This is just data. So you can then change there and go. Want the data to be Brazil, right? And we're looking at cloud response time. So I don't want to look at cloud. I want to look at CDN response time. Let's say. If you're video, you might want to look at throughput, but and then that
No,
kind of
web
gives
page.
you. So that anonymous CDN is actually Akamai. So the number 1 and number 2 are Akamai right now, right this second.
Okay.
And at 41 milliseconds and 43
So I see
milliseconds.
how it goes, but the difference is not
The
that
difference is
big.
pretty small if you scroll all the way down. Scroll
Yeah.
Well, I
down.
mean, by the time you get to 65 milliseconds or whatever, it starts to get pretty cruddy, and then obviously it goes all the way down to 85 here. So yeah, but what I would urge you to do, because the much more interesting time-based data is actually you create a login, and this is his machine. He's already got a login, but you just go to that upper right-hand button, and this is what the radar tag looks like actually right here. That's the tag you would put on your site at the bottom, and then you would actually be able to go look at your data. So if you wanted to go look at under radar, under performance report, you could say, I really care about the country, Brazil, B-R-A-Z-I-L, B-R-A-Z-I-L, Brazil. Let's say you cared about Akamai, object delivery. Let's say I cared about Edgecast, small, let's say I care about high winds. Again, there's about 20 of these guys, right? So you can check these 3, and you can see who's doing. This is latency, so they're the lower is better. And then you can start drilling into regions of Brazil. So you can say northwest, who's winning in northwest, and
Because for me, it makes sense that I see what's the baseline, what the average gets. Because when I be worse, then I know I have different problem.
Yeah, and the one thing to realize on this gives you a set of data to start looking at the direction you want to take, but it's not illustrative of what your workflow is. So these
That's
are
right.
like the Sodexo's data,
Yes.
small amounts of data that you're pulling back. It's what's the size we have?
you got the 42K file, which is the small. So what happens is, as I mentioned, Bloomberg. Someone reads Bloomberg, and at the bottom, the piece of JavaScript wakes up, and it goes out there, and it says, to find round trip time, it goes and takes that small file, which is less than 1 packet size, and moves it back and forth once. Okay, that's now your round trip time. And then the large file is a 100K file, which is not entirely representative of truly large files, but we do some math on it to actually calculate throughput. So that's how we get the throughput numbers. That's how we get the latency numbers. And then availability is just an attempt to connect. And if it fails, that's
Sure.
yeah. So
Oh, that's good to know.
So use it as a baseline, but still, we
Yeah, yeah.
always say it's like use your workflow and actually test it out end to end.
yeah.
as long
Oh,
as
and that's
you
actually what I was
do
going to
that.
show you. So once you have implemented, is this our mouse or?
Oh, there you go.
So you can actually go say only my visitors. See, and we don't have a tag deployed for this particular user ID,
Okay.
but if you once you deploy the tag, you can then go see how your visitors are experiencing. Which you're gonna. What's interesting about that is you do find that particular sites, particular verticals, like if you're a B2B site, you're going to be your users are often going to be on well-connected networks in office buildings. If you're a B2C site, not so much. If you're a mobile site, whole different set of. So these numbers are interesting, but this is all the users, right?
Yes.
You know,
But this is,
your
for me,
user
is
set.
a good starting point
No,
to
no.
discuss with the company because
Yep.
it's a large manufacturer.
Okay.
They use a SharePoint site to push actually construction plans and so on for
Sure. Big files.
big files.
So throughput's what you're going to care
to the
about.
technician,
Sure.
constructors, to factories on place.
Yeah. So you want
Um,
to change. You want to go here.
That's why we asked for private content
Yep,
because
yep.
some of them. I mean, what I'm doing now is on the library itself. I have a tagging,
Mm-hmm.
and it depends on the sensitivity. Either I use RMS to actually encrypt it before we put it
Put it out,
public,
yeah.
Mm-hmm. Yeah.
or it goes public because actually it is. So now I'm obviously and now I'm look what the SharePoint team brings itself.
Sure.
Because it might replace what we do, or it might add. So difficult to see. But what we had actually is in Wuji and in Sao Paulo, we have actually problem with the access times to the
Yep.
content, and we in discussion with the customer how we could do it better.
Yeah. Sounds like throughput's going to be your friend, though, right? You're going to want to like optimize for throughput as much as you can because these are.
Yeah,
How big is your average file?
Yeah, I mean, a real construction plan can be easily up to 30 meg.
30 meg. Yeah. So that can take a minute to download in Brazil.
Yeah.
Yeah. Sure.
Yeah, you're also dealing with the, I always say, massive amount of build out in South America, but it's also that,
Smart.
yeah, one's yours. But like the peering is not a mature environment there. You know, it's like you would think that traffic would just flow across country boundaries, and it doesn't. So you're trying to go from Argentina to Brazil and other things. It's like
It's always going through Miami.
it's going through Miami, it's popping out.
Why is it
So
always
many
going to
pieces,
Miami?
so,
No, that's why we implemented already some infrastructure that we do, like we have Armin agents out there,
Yep.
and we do trace routes. So because we were pretty passionate, put pressure on us to make it better. And
Yep.
yeah.
Well, if we can help, let us know. I mean, if
Yeah, it's always good to
Nice to meet you.
broaden
Yeah.
the knowledge. Huh?
Yep.
And thank you very much. You were in contact with a colleague of mine.
Okay.
And we got this 15 endpoints for one profile.
Okay, yeah, now I remember that. Yes, now I remember. Yes. Yes.
Okay.
Good meeting you.